Okay, so here we go. We should be online now. Oops. Let's just see. Yeah. Okay, so tonight, what are we going to do? We are going to, so tonight we're going to basically work on scraping more sites and then caching data. And figuring out how exactly to, I guess, per se, cache the data into the result section. Oh wait, that's not the project. So those are going to be the main things, basically. But basically, yeah, we're going to run this and then cache some of the data from the, essentially, from the Weather data into the BigQuery table and hopefully start populating that. And then we might also make the actual tables for the combined flow depending on how much time we have. And then we're also going to create probably a script to upload. So we are going to save async copies just as replicas in GCS. So we will maintain the raw CSV file because that should cost very little. It's CSV data, and then we also have the raw stuff maintained of the scrape in case that's more useful for various reasons. But we also have to think about a caching storage engine. I looked at Memcache the other day on GCP or Memory Store. So that would be the easiest thing to use. Unfortunately, it's pricey. And since basically I'm footing all the costs for this project right now, I don't really want to throw up a Redis cluster. Again, basically the idea with this cache is that it's just this thing to store what dates have already, or what dates for what weather stations and rivers have already been scraped, so we don't end up inserting duplicates into the table, which then we have to like deduplicate later, or just so that we don't run the same code again because it can get expensive. But where to store it is kind of a fairly good question. So yeah, that's one of the things we might want to look at. Basically, it looks like even for the smallest thing on Memcache, it would probably be around $46 a month, and that's only if you were using, I think, like 2 or 3 gigabytes. I might see if there's anything on Redis Cloud for free to see about that, but at the moment, I think we're going to worry about that later and first get the code to actually get the scrape all squared away, and then we'll worry about caching when we scrape through a lot of things at once later. So with that said, basically, yeah, we'll get started on that. Example tile. Okay, I think I can close that. So, and then quit. Yeah, I'll quit that for now. Yeah, I was just looking at some of the satellite imagery. Actually in that. So, what we can do is, quit that too. So yeah, let's go here. We're at least not going to set up the Memcache thing until this is all actually done correctly. So one of the things here to do, so we have this write to BQ function. For the weather data, so I'm going to add in here basically the writing. Looks like there are too many blank lines now. To the BQ table, into here. But yeah, that once we do that, tests are actually going to probably start to fail and stuff. Scraping functions. So I'm probably going to, I'm going to remember what PR I had this under actually first. Cause yeah, I want to get all my branches squared away. What the fuck is this? Yeah, so this is why you don't want to have vague PRs like this. To write tables to GCP and scraping NB. So basically that's what this covers, I think. I think we accidentally committed some of these files here too, which it's not awful but not great. And then so that's there, but we'll probably go and look at seeing getting this thing all set. So when we like concluded the other night, basically we had just started to write into infra FlowDB. Where is this? Riverflow notebooks, LS. So when we had started the other night, we just started to write into this sort of thing. So so here we have so yeah, we're basically going to now, I think we had updated the code to actually add all those fields. So now in our test, we're just going to quickly check that first of all, we're going to discard everything that we didn't want to keep right now. So I think that was all these files basically. So yeah, we will just try running this again, I think, the test that is. So let's see if these run. And that's gonna regenerate most of those files anyways. So we'll see if it actually writes to the BQ table. We might actually get an error since we're now adding new fields to a table that we already kind of inferred the schema on. Which would probably cause an error. Yeah. Yeah, so that's exactly what this thing is, because we added new things. It's now throwing an error. So I'm actually going to delete that old table since it was just a test table anyways. And then go from there. So for that, let's pull up BigQuery. Okay, I think we can Hydronet. Yeah, so the table, it didn't copy the right shit. We're now going to rerun it with the table. So just wait for that to... So we'll just wait for that to rerun. We can check on terminal. So it's running. I might go and update some of the things here, like what we're actually looking to do. So data. Okay, so basically this should be done by now. Looks like it ran everything okay. So if we check back here, the table should have been created. Shit, those are all my tables. So here's the table, it looks like, and now we have basically everything in it. Though a lot of these values are missing. But that's all right. So 20. So that seems to be working. So now, what we want to do is, let's just double check with that weather function that everything is working right. That everything is in here, I mean, peak wind gust. I think this is everything we said before. Should be in the schema. I'll just double check. So one of the things we're doing right now is we're actually not using the schema we had created in Terraform, or rather using an inferred schema, because it was kind of a pain in the ass actually to match it to the Terraform schema. So that would probably be the best long run for the overall longevity of it. But now I'm just checking that the schema kind of will roughly match gust, visibility, feel, percip. Is everything in there? Fuck. Where my things go? Too many windows open. So yeah, I think everything's in there though, so we'll just not worry about that. Percep, blah blah blah, that's in there. Direction, speed, alt E, sknet. Yeah, looks like everything's in there, so we're not gonna worry about that then. So things are getting written to the table, which is good. And so one of the things about doing before we actually run this as tests, or actually we can see now it's probably failing because it doesn't have our GCP credentials on Circle CI during these tests. So yeah, your credentials aren't found. So we probably have to set up the credentials. GCP somehow. So add key. So yeah, we probably have to add okay, we're not creating, I think, a container at the moment. So we probably just actually have to do these steps. I'm not going to do that on here because I'd have to block out most of my screen anyways. But basically the idea would be we create kind of a service account, and then we create a JSON file, and then we take that and add it as an environmental variable. I guess, yeah, we add basically the whole JSON as an environment variable. And then we add these two other environmental variables, and that should help. This is for if we are pushing a container to GCR, which we're not doing. So we probably don't have to actually do that step. So yeah, I won't do that now, but essentially that is something I'll have to do to make the test pass there, because otherwise they're just going to keep running. Now that that big query thing is in there, they're going to run and not find it, and then that's going to cause the test to fail. In any case, going back here, so now that that's kind of working, the next thing we want to do is actually add that to the actual scraper code, so that after it gets this thing, it then writes to this thing to GCS. So then from here we're going to call self dot bq connect, and then write to bq. ASOS Weber. So I guess that's what we'll call it. Actually, we should probably have this specified for. So actually, yeah, this is a good point. We should have this specified for tests as a table. So we can distinguish between test versus prod.